In this short video, I'll go through the main points from the metric mania notes. The first thing I'm going to talk about is why we use the metric system in science. To start off with, it's more precise and accurate than the US customary system or the English imperial system as we use in the United States. Alright, one thing that makes it very precise and accurate is that the metric prefixes allow us to measure things to a really small degree, such as nanometers. Alright, and also it actually allows us to measure things that are very large using metric prefixes like the yottameter, which can measure the space between galaxies and things like that, very large sizes in space. And so the metric system is actually very versatile and allows us to measure a lot of different quantities with these different sorts of units. And so the metric system is just better in that way. The other thing is all of those prefixes are based on 10, which makes the math very easy in the metric system. Everything is based on 10. If you think of the US customary system, we have things like 12 inches in a foot and 3 feet in a yard and 5,280 feet in a mile. And all of that is based on a really archaic system of measurements that didn't really fit well together, and the math is terrible to use. And so the metric system being based on 10 is just a lot better. Also, the metric system is universal, which means that people use it all over the place. It's very easy to use. It just makes intuitive sense. And as you'll see on this next slide, there are a lot of different countries that use it. It's actually called the international system or the system international. Alright, so there are countries all over the world that use this. Actually here outlined in green are all the countries that use it. You can see that it's most of the countries in the world. Here in red are the countries that don't use the metric system. We've got the United States, and then the only two other countries that don't use it are Liberia and Myanmar, otherwise known as Burma. And so there are only three countries in the United States three countries in the world that do not use the metric system. It's used almost everywhere. So it just makes more sense if you're communicating with all of these other people in other parts of the world that you're going to use the same system of measurements that they use. So I'm going to talk now about the different units of measurement in the metric system. And so the first one I'm going to talk about here is the gram. The gram is a unit used to measure mass. And mass is the amount of matter in something. So matter is made up of tiny little things called atoms. And those atoms, they make up everything in the universe. And you can measure how many atoms, how many subatomic particles there are in a substance by finding its mass. So you can think of that generally as the amount of particles that make up a substance, that is its mass. The meter is the base unit that we use to measure length. Alright, and anytime we're measuring length, it is a one-dimensional measurement, and it just measures distance between any 2 points in space. The liter is the base unit in the metric system to measure volume, which is the amount of space something takes up. When you think of volume, think three-dimensional space. It has length and width and height, and so the liter is what we use there for volume. Also, of course, you've seen in class, we use things like centimeters cubed for volume, and so by cubing a length unit, we can get a volume unit. Temperature in the English system is measured in degrees Celsius, which you've probably encountered at some point in your education. It is just similar to Fahrenheit, but it's on a different sort of system. It's actually based on water, as you'll see here on this next slide. What we have here is some just reference points to use when comparing Celsius to Fahrenheit. Something that I want to point out is the boiling point of water in Celsius is 100 degrees. In Fahrenheit, it's 212. And then the freezing point of water is 0 in Celsius, and it's 32 in Fahrenheit. As I said, Celsius is based on water, so 0 is the freezing point of water, 100 is the boiling point of water, and then each degree in between is just 1/100th of the difference in temperature between freezing and boiling for water. You can read through those and pause the video and kind of get an idea of how Celsius compares to Fahrenheit in that way. The next thing I'm going to talk about is density. As we've talked about in class, density is a ratio between the mass in a substance and its volume. Mass, again, is the amount of matter that's in something. And so, as you can see here, we've got two different boxes on the bottom. And in one of the boxes, the matter is spread out. That would be low density. And in the other box, the matter is really compact, and that would represent something that was high density. The size of the object doesn't matter because it's just a ratio, so you can have something that's very, very small but still very dense. As long as it has a bunch of atoms that are compacted into a small space, it is dense. So as you read through this question here, again, maybe pause the video and think about it. It says that we've got cube A and it has a greater density than cube B, and the question is, how can this be? If cube A is smaller than cube B, how is it that it can have a greater density? If you think about it now, going back to what I had just said on the previous slide, cube A can be more dense than cube B. All that means is that the atoms are more compact, they're closer together. All right, and so you can see here in this picture, cube A has a lot of atoms packed into that small space, whereas the atoms are more spread out in cube B. All right, that would make cube A more dense than cube B, despite the fact that cube B was larger. Now I'm going to go into talking about some of the tools that we use in measuring things in the metric system. The first one is called the electronic balance. You can see that in the top right corner. What you do there is you just set an item on the balance and then it will read a measurement of the mass. We always measure mass in grams, so you want to make sure that your electric balance is set to grams and also that it starts out at 0. If the electric balance doesn't say 0, there's always a 0 or a tare button on it that will set it back to 0 or recalibrate it. The next tool I'm going to talk about is just the meter stick or the ruler. When you're using a meter stick or a ruler, make sure that it is measuring in centimeters because that's usually what we use for length. The next thing, to measure volume, especially if we're talking about volume of liquids or if we find the volume of irregular objects by water displacement, we're going to use the graduated cylinder. The graduated cylinder has a little curve in the bottom of it. It has a curve in the water because water is attracted to the sides of the graduated cylinder in a process known as adhesion. And so because of this, it makes it a little bit confusing to read the graduated cylinder. You might ask if you read from the top of the curve or the bottom of the curve. Well, that curve is called the meniscus, and you actually have to read from the bottom of that curve. So make sure that whenever you read a graduated cylinder, you're viewing it from straight on and you're measuring from the bottom of the meniscus. The last thing is just we use a thermometer to measure the temperature of a substance, and I'll remind you that the temperature measures the motion of particles within a substance. If something is hot, that means that its atoms and its molecules are moving really, really quickly within the substance. If something is cold, that means its atoms are moving relatively slowly within that substance. Now I'm going to talk about some formulas you need to know. You're going to need to know how to calculate the area of a rectangle. That is just length times width. All right. A rectangle is a two-dimensional object. Anytime that you're calculating area, we're going to be talking about a two-dimensional object. What that means is it's something that's flat. Think about like something like a piece of paper where it has length and it has width, but it doesn't really have depth. That would be something sort of two-dimensional. Technically speaking, papers do have a very, very thin third dimension, but as I said, just imagine things that are pretty flat, like the surface of an object, something that's flat and that's two-dimensional. You get the area by taking the length and multiplying times the width. For volume, we're talking about something that is three-dimensional, which means it has length and width and depth, or length and width and height. And with that, you measure the three sides of it and you multiply them by each other. I want to mention here, because area is two-dimensional, it has units of centimeters squared when you calculate it, or some length unit squared. For volume, because it's three-dimensional, we take length times width times height. What you're going to get there is a three-dimensional quantity, so it should have units of centimeters cubed or some length unit cubed. And then again, if you're doing the volume of an irregular object, you need to use water displacement. So what you do is you take that object, you fill a graduated cylinder with some water, you read an initial reading on the graduated cylinder, you put the object in, you take the reading again, all right, and the difference in the level of water that you have there is the mass of the object. So we see here a rock that is submerged on the picture at the bottom right. The graduated cylinder started out at 50 milliliters. You put the rock in there, the level rose to 75 milliliters. That would indicate that the rock has a volume of 25 milliliters, because the difference there in the volume between the first measurement and the second measurement is the space that is taken up by the rock. All right, so you just take that second measurement minus the first measurement. And again, as a second reminder, always measure from the bottom of that meniscus. The next formula I'm going to talk about is the formula for calculating density. It is mass over volume. All right, so something here that is confusing to people are the units on density. And for this, what you have to remember is, first, the units on mass is grams, and the units on volume, typically speaking in this class, is going to be centimeters cubed or milliliters. All right, and so the units on your density are going to be the units on mass over the units on volume. So like grams per centimeter cubed or grams per milliliter. Make sure that that makes sense to you and that you correctly identify the units on density when you go through those calculations. The next thing I'm going to talk about here is some comparisons for the metric system, so that you kind of get an idea of what the different measurements represent when you hear a term. And so I've got a bunch of different comparisons here. One thing you might think of is 1 millimeter. That is about the thickness of a pencil lead. And when I say thickness, I mean if you looked at a pencil straight on, just what it would look like. Some of you in your mechanical pencils will use 0.7 millimeter lead or 0.9 millimeter lead. That's slightly smaller than a millimeter. A centimeter is about the width of your finger, and again, this is not the length of your finger, it's the width. So if you point, say, your finger straight at your face, the width would be how wide it is when you're looking at it pointed straight at you. A decimeter is about the width of your palm. That is 1/10 of a meter. All right, and a meter itself is about the length of a leg, and in fact, it's the length of a leg of someone who's relatively tall. So think of a relatively tall adult, someone who's 6 feet or higher, probably would have about a meter in length for their leg. And then kilometers are about half a mile. They're a little bit more than half a mile, and we use those to measure distances on a larger scale, and so you can kind of think of them that way. The next thing I'm going to talk about is mass. Mass measures, again, the amount of matter in a substance, and so to give you an idea of what that is, 1 gram is about the mass of a paper clip. So paper clips you can think of are relatively small objects, so a gram is not that much in terms of mass. A kilogram, which is 1,000 grams, which would be like 1,000 of those paper clips, would weigh the amount of a small book or a small dictionary or something like that. So a kilogram is 1,000 grams, and as I said, you can think of it that way. A milliliter is a very small amount too. So if you think about a teaspoon that you would use in baking, a teaspoon is 1/3 of a tablespoon. So a teaspoon is already very small. And a milliliter is actually 1/4 of a teaspoon. So not very large at all. A liter, which is 1,000 milliliters, is quite a bit larger. It's something that you might be familiar with. You see there I have a bottle of water depicted there. So you can get bottles of water that are in the size of a liter, or a lot of times you would buy soda pop, and it will be in 2-liter bottles. And so when you think about liters, kind of think about those things in reference to what a liter is. So based on this, go ahead and try and think about these different things and what they'd be measured in. If you want to pause the video and think about it for a couple seconds on each one and then kind of make a guess, I will tell you after that how long each of these is, or what the appropriate unit you should use to measure each of these would be. So thinking of the length of an eyelash, try and decide what makes the most sense: a millimeter, a centimeter, a meter, or a kilometer. In this case, a millimeter probably makes the most sense. An eyelash is very short, and so it wouldn't be very many millimeters. Maybe you might use a centimeter to measure it, although your eyelash probably wouldn't be much longer than 1 centimeter, so a millimeter makes probably the most sense here. The height of a flagpole, think about the flagpole, say, in front of West High School. In this case, meters would make the most sense. Centimeters are pretty small. It would be a number of meters to get up to the top of a flagpole, like maybe 10 or 20 meters to get that to the height of a flagpole. Kilometers are way too large, though. The mass of a person. Okay, in this case, kilograms makes the most sense. Remember, a gram is about the size of a paperclip. A milligram and a centigram are even smaller than that. All right, and so kilogram, which is 1,000 grams, makes the most sense here. We said it was about the size of a small dictionary or something like that. The mass of a pencil. For that one, we're going to use grams. Grams seems appropriate. A pencil would be, some number of paper clips, maybe like 40 paper clips, 40 grams for a pencil. The distance from Chicago to Minneapolis. In this case, kilometers probably makes the most sense. Kilometers are sort of analogous to miles, all right, and so a distance on a map you would probably measure in kilometers. So that is everything from this set of notes. If there's anything that confuses you from this, make sure that you come and ask me or another Foundations of Science teacher. We want to make sure that you understand these ideas because we're going to be using them throughout the rest of the year, and it's just really important basic understanding to have about the way that the metric system works and the units that we use.